All right. Looks like we're recording.
Yep, it just told me. So one of the ideas I had was to see if there was any other form of coordinate system or anything that we could look at that other than Cartesian and polar. And I couldn't find anything from what I was looking at. Obviously, there's 3D versions of both of those. So squares and spherical, but I find another way to translate the points, which I'd never heard of one, so I didn't think there was one. But just from what I was looking at, I couldn't find anything. And then the other thing I was thinking about, I think Rich or you or someone may have brought this up in class, but you get the point, and then from there, I don't know, you reset the coordinates, so it's that's now 0, 0, and then I don't know if that would actually be any different than just moving from point to point, but I just thought maybe it could help the system predict better or not, since it's just staying in the same system. I don't actually know. Thinking about it now, I don't actually know if that would do anything different from just having the regular coordinates. You know what I mean?
Yeah. So I think you were kind of talking about a change of basis type thing.
Yeah. But I don't know if that would really help it or just add more work and just give it the same information, you know?
Yeah. So I've been kind of playing with a distance matrix, and I meant to send you the Excel sheet. I can send you both my MATLAB thing where I'm just playing around and the Excel sheet I got from that, where it basically just kind of I force it to start at 1, and then from there it basically looks at the distance matrix. If you think of it, the row is from this, and then the column is the 2 node. So you're going if you start on row 1, and then you look at all of the other values on that row and say which one's the minimum, then you pick that one, and then you take that column, and that becomes your next row that you look at, and you say, okay, now take the minimum. And I had to mess with it a bit because what was going on was it was kind of short circuiting. And what I realized was I had to set it to where I had to kind of use big M to keep it from going back to the same node and revisiting a node more than once. But see, I don't know that it was actually, I didn't get the chance to actually compare it to polar at all. To see, I was having some trouble. I kind of ran it both with and without the genetic algorithm. And so stupid technology. Anyway.
So you said that you had Big M, or you had tried Big M to make it not go back to the same nodes it had already tried.
Yeah, and that way, and actually, let me just share my screen and show you the MATLAB. So actually, why should I send you a separate MATLAB thing? I can just do the MATLAB here, because this is all I'm going to really put in the MATLAB anyway. And then I can send you the Excel file I have, or if you want to generate a different one. So I've got the same 20 points. Oh, and this was just kind of testing whether the original versus the stuff I manipulated was better in the genetic algorithm. It pretty much came out to the same result each time. So, so this just kind of saved that. And I'm just gonna copy this down here because it'll save user config. There we go. So then I sort by the x's and remake this xy into sorted xy's. So I found this function pdist, which gives the distance matrix and then puts it in a nice form for us. And so what this does...
If you're sharing your screen, it's not coming through.
Oh, that's weird. Try again. Can you see it now?
No, it's just showing me HM right now.
That's so weird. Let me try turning the camera on or something.
Oh, that just changed. I see a blue screen now. Oh, it went away.
All right.
There we go.
See the MATLAB?
Yep.
Okay, perfect. So you didn't miss much. I just, the 20 points sorted. There's this function which gives the distance matrix in a square form. And so what this is, because each node distance from the node to itself is 0. So because I didn't want that showing up as the minimum, I used big M there. Store the sequence. Can you still hear me? I'm getting a bad network quality thing.
Yeah.
Okay. So then I set the first one equal to 1, and initialize these two. And then I kind of go through, I don't think this is Dijkstra's, but it's kind of similar. Well, actually, no, it's definitely not Dijkstra's. I did find, and I downloaded the code for Dijkstra's, and I'd like to try this because, and then we can kind of do like a thing like Miranda was doing where it just sort of like sorts it. But I'd be very surprised if Dijkstra's didn't give a very good warm start because it's literally an algorithm to find the shortest path through any given node. So anyway, but what mine does.
That's what Rich was mentioning, or did you say that was what Miranda brought up?
I think what Miranda did was they kind of got their sequence in like a sorted order. So that way it would start with either lower or higher values and then increase or decrease respectively.
Okay, yeah, that makes sense.
Yeah, so all this is doing here is it's noting where it's gone. It takes the minimum and captures the index of it, puts that in the sequence, puts the appropriate coordinates where they are, and captures the total distance. And then I use big M so that it doesn't return to the same node again. And then I put them back in an XY matrix to be put into the second user configuration to pass to the genetic algorithm here, output the sequence and the total distance. So if I run it, I'll just do run in time, because why not? So down here, so this is the sequence, and you can see it is starting smaller and generally getting larger.
Yeah, that's what
you cut out. You said that's what?
Yeah, that's what Rich was looking for, right? It's generally in the same order, but it's not always, it's not going to be exactly in the same order.
Right. I think so. So, let's see. All right. So now we have, computer's freezing. So it does produce the same path, and we have total time, which, the TSP runs for the most amount of time. And I was having a hard time getting it like separated from the rest of the algorithm. Obviously, this part doesn't take much. And wow, actually, if you can see both times the genetic algorithm, both with the original just random coordinates and with our sorted coordinates, they both produce 3.6 in terms of the minimum distance. And ours produced not only a more orderly sequence, but it produced a better distance. That's pretty cool.
Yeah, I do see that. So that would probably be something he's looking for, right? He said a notable like difference or a difference.
It doesn't always happen. Let me just try running it again, even without the time, and just see what it comes up with. Because see, now the genetic algorithm's doing better.
Okay.
But this is sorting it by, see, what did I sort by? X. We could also try, sorting it by Y and seeing what happens there. And of course, we'd have to try sorting it by polar coordinates too and seeing. But I mean, polar coordinates just give an order. It doesn't necessarily, I mean, the distance is still the same. So polar coordinates, it wouldn't really matter. You know what I mean?
Yeah.
So all it is sorting by X or sorting by Y, it's just a matter of whether the sequence looks pretty or not.
Uh-huh. Yeah, so I'm looking at the numbers there. Is he are those too much out of order there, or like with the 2, 4, 10, 12, 15 and then back? Or is that acceptable for what he was looking for, do you think?
I think this is too much out of order. At least for a machine learning example.
Mm-hmm.
And we'd have to run it hundreds of times. But the key is whether we can get something that's a warm start. And see, I just don't know whether it's truly because like these, obviously this is the original, and then this is with the new sequence that we passed in of coordinates, and they come to the same answer, which doesn't necessarily mean that ours is bad, but I just don't know how to get the time. You know what I'm saying?
Mm-hmm.
Because if we generate random, I mean, I guess we can like generate random with one and time it like with our algorithm, and then copy over the random values and run it with TSPGA and see how long it takes. And it could be, hundredths of a second, but that might make a difference. That might be statistically significant. So
here we are in MATLAB. We have the TSPGA code provided to us by Professor Rich and the MATLAB code written by Hannah. So as you can see, I have run it here, and I will run it again. This is using a random sequence of 20 coordinates. So it runs through, ignore the errors, we're still working on some things right now. And here you can see it gives you a sequence of the 20 points and then a total distance for them. The distance is small because the points are all in decimals. And over here in Excel, I have a random sequence that I had previously generated. So you can see here 1 through 20 points, and then this is the distance. And then using that for a warm start, I then went and made this sequence, putting it into the TSPGA problem. This is the total distance, and then this sequence I used again in this run here to give me a slightly better total distance as well.